Alright, so we are going to walk through a sample application and discover cache diagnostics. So our sample application is a simple exchange rate application. It's a visual force page that will look like this. So base currency is US dollar, to which currency, and this is the exchange rate for the day. So this example application is retrieving the rates for the day, not by the hour, not by the minute. Alright, so here we base our exchange rate sample application on a visual force page and an Apex controller that contains the logic for fetching exchange rates, right? The first time this page is accessed, the rates are obtained through an API call to an external web service. So for example, we are grabbing it from Yahoo Finance or any other exchange rates API provider. At the beginning of the day, the first time it's accessed, it's going to pull that and then store it in a cache. The second time and sequential time of the day it's being accessed is going to retrieve the rates from the cache. So we are not going to make an additional API call anymore. Okay, so that's the application. This is the visual page. So controller is the exchange rate. The first action is init, and then it's just gonna do a page block and page block table, which will display the base currency, the to currency, and the rate, which is simple. These three columns, right? The column, Apex column. So we have the sample Apex controller, which is a pretty long code. So I'm not going to go line by line with you here. So basically, here is what it's doing. When it's first being accessed, it's going to do an API call. And if it's not the first time, it's going to retrieve it from the cache. Okay, so if it's not the first time, raise get cache rates. Otherwise, it will do a sockle or a API call, web service. Alright, so that's basically what it's doing, but we're not talking about the code here. We are going to do a analysis, walk through a sample application and discover cache diagnostic. Okay, so pattern for cache storage. The exchange rates Apex class contains methods that encapsulate the logic of initializing and refreshing the cache. So initializing and refreshing the cache. If the data is stale or not found, the init method retrieves the new exchange rate through an API call and then stores them in Salesforce. The getCacheRates method manages the cache internally. If the cached value is not found, this method retrieves an array of rates from Salesforce and stores it in the cache. Because our app uses external data, it fetches data from a web service through API calls. It also stores the data as Salesforce records as a backup for refreshing the cache. Apps that don't use external data retrieve Salesforce records by using sockle and cache it. So in this case, the process of cache management is simpler and the cache method implementation is shorter. For example, if your app just uses local data from sockle, you would not need the init method but only the getCacheRates method. So I hope that makes sense. So deciding what to cache. Alright? So deciding what to cache. This sample stores an array of S objects in the cache. Is this approach the best choice of data structure to store? There are trade-offs with every choice you make. Storing smaller pieces of data like field values instead of the entire as objects can reduce your cache usage size. But if you store less data in each key, you might need complex logic to rebuild the data as objects, which requires more processing time, right? And an as object array stored in one key uses less cache space, so one key, less space, of course, than the total size of individual as objects stored in individual keys. So if you can store it in one key, do so if it's possible. All right. So you can put the rates on here, right? Or you can also store individual rates like so, right? So this is 3 keys. This is just one key. Put it as a list. All right. So that's that. Diagnose cache usage. So we can diagnose the cache usage. First, you have to enable it for the user. So you go setup users and then cache diagnostics. You have to select that and then save for that user. And then for that user to access it, setup and then cache and then platform cache, and then you can under session cache or cache, click diagnostic there. So it's going to pop this up and you can see this where you can see the usage of each key. If it's rates, if it's a dollar to Chinese yuan, dollar to Japanese yuan, dollar to euro rate, right? So if it's a list, see the size is a bit bigger, right? If it's every dollar is multiple keys, the size is lesser, but it is using 4 keys. All right. So yeah, so you can analyze it like that and see how your cache is being used, how many times it's being used, and so on. So you can design your application more efficiently. Okay, that's pretty much it. So let's do the quiz here. An API call to fetch data takes the most time, right? SQL queries are faster, yeah, and fetching data from the cache is the fastest way to get data. When should you use API or SQL queries then compared to the cache? Make API calls to refresh external data when necessary. Yep. Optionally store data in Salesforce temporarily as a way to resupply the cache without having to make API calls often. Yes. Get the data from the cache whenever possible. Yeah, this is good. So in ANC, this is usually like that, right? Let's see. Make API calls on a regular basis? No. When not using external data from API web service, retrieve data from Salesforce through SQL queries, right? To refresh your data when necessary and store data in the cache for fast retrieval. Yeah. So A and C. Number 2. Your app displays data using a list of custom object records. The purpose is to reduce app processing time. Assume your app is below cache storage limits. So assume your app is below cache storage limit. How should the cache values be stored? One key, right? So this is multiple key, no? One key, right? One key is better, like a list stored in one key. Your app display bus schedules for transportation agency. Storing all the schedules in the cache would exceed cache limits. You can't store it all in the cache. You know that only a handful of bus schedules are requested most. Which of the following options are best to store schedules in the cache? A list of randomly? No, that's already bad. Randomly. That's already bad, right? Assuming that the list of most requested schedules is provided and doesn't change, store the most requested schedules and a key for each bus schedules. Yeah, that's good, right? All schedules stored in separate keys. The key used list recently might get evicted from the cache. That could work as well. So I would choose B and C. So let's see. Hopefully we get it all. Bada bing, bada boom. Woohoo! We've got a shiny new badge. So I'll see you on the next section. Bada bing, bada boom. Hit that subscribe button and explore new Trailhead grounds and learn to implement the most useful and popular apps on the Salesforce App Exchange. And do yourself a favor, like this video and you'll be surprised on how much more you understand when watching this same video after liking it. Don't take my word. Watch this one more time after you like the video and see it for yourself. Bada bing, bada boom.